Alright, today's objective is that I can solve logarithmic equations. We are going to do 10.5 today. Just a reminder, you want to make sure you've done 10.3a, 10.3b, 10.3c, and 10.4. In green up here, you can see that our last unit test is this Friday, so you want to take seriously the review on Thursday so you can be ready for your test, your last big normal grade for the 9 weeks before our final. Okay. Grades are going to be temporarily frozen after today because of exam exemptions. So the exam exemption window is from Wednesday to Friday. So I have to put in grades today, and they will not be able to be updated until after Friday. So make sure you got stuff turned in today. Let's do this warm-up. By the way, make sure if for some reason you borrowed a calculator and it's in your bag or something at home, you can bring that back because I need my calculators back big time. Okay, so please check your bags, check at home. I need those, please. Okay, also Stars play tonight, go Stars. Now, let's simplify this log here. Hopefully you remember, if there's a number out front in front of a log, that's going to become the exponent of this argument on the inside of the parentheses. So remember, that's going to be log of x to the power of 3, or x cubed, minus log of y to the power 2, or y squared. Okay, so any numbers out front, you bring it up top. And then remember, if there's subtraction, that means you're going to divide on the inside of the argument. So this kind of turns into one log. And remember, if there's no base, you don't have to write a base. So it's just log. And inside the parentheses, we're going to have that x to the third power on top, divided by y squared on the bottom. Hopefully y'all can see that. So remember, any coefficient in front of a log becomes the exponent inside the parentheses. That's called the argument. And then if you're subtracting logs, you can turn that into one log, combine them, but you have to be dividing what was in those arguments inside the parentheses. Okay. Now you should have the 10.5 notes. We're going to pass those out if you don't already have them. And those 10.5 notes look like this. Okay, so I'm going to show you the PowerPoint on the left, and we can write on it on the right here. And then if we need to, we'll pull up our calculator. Cool. All right. So first thing on our notes, it says an exponential equation is an equation where the variable is an exponent. Okay, exponential, x is in the exponent. So when the exponential equation cannot be easily rewritten with equal bases, we can use the logarithmic power rule to solve those exponential equations, which means you take that x in the exponent, bring it out front. Okay, this is stuff we learned in 10.3c, and we kind of went over it in our warm-up. Okay, so here's our steps. Keep the exponential expression by itself on one side of the equation. Step 2, get the logarithms of both sides of the equation. You can use any base for the logs. And then step 3, solve for the variable. Keep the answer exact or give decimal approximations. So here's our basic rules. Any log of the number 1 is going to give you 0. Log base b, if the base matches what's in the argument in the parentheses, that's going to give you 1. And log e, or natural log, okay, those are the same thing. So natural log of 1 is also 0. Natural log of e, because the base is e, is going to equal 1. And then natural log of e to the x, you pull out x in front, and then natural log of e, we already know is 1, so x times 1 is x, okay? There's a YouTube there, but let's keep going. Let's solve example number 1, okay? So I see x is in the exponent, so my first step is to do my log rules. So I know, okay, that log, my base is going to become my little base here. This is going to be my argument, and that equals the exponent. Okay, y'all remember doing this? 10.1, 10.2? Okay. Now, here's the deal. If x equals this, then I can put this in my calculator. So remember, when I'm doing logs, I'm going to do control 10 to the x, which is next to the number 1. I'm going to have a little base 3, go to the right, 683, hit enter, and I get 9. That's it. Cool. But I got to do that switcheroo thing, and then once it's x equals, now I can actually just plug that in the calculator. Cool. Let's talk about example 2. All right, now this is weird because instead of just 4 to the x, there's a 7 out front. So anytime you have something out front, like a coefficient, we got to divide that on both sides. Okay, so now I have 4 to the x equals 128. And now I can do that trick. All right, my log, the base becomes the little base. What it equals to is the argument. And that equals the exponent. Okay. So now I can plug this in the calculator. Control 10 to the x, which is next to the number 1, little 4, go to the right, 128, and I get 3.5. Cool. Do you see how that works? Whatever the base is of the exponent becomes the base of the log. Whatever it equaled becomes the argument in the parentheses. Whatever the exponent is goes to the right. It becomes what it equals. And now that x is by itself, plug it in the calculator. A couple more. We are going to flip the page over to example 3. All right, let's do this. So once again, I see I have an exponent out front. Sorry, a coefficient out front. So to get rid of the 6 in front, I got to divide by 6, divide by 6. So now I have 3 to the x minus 1 equals, what's 1,458 divided by 6? 243. All right, cool. Now, next step, see that x minus 1? That is going to come down, okay, when we do this. So check it out. We're going to use the same log rule, right? The word log. Oops. Okay, the base is the base, little base. Okay, what it equals is now the argument, and that equals the exponent, x minus 1. Right? We don't really need those parentheses. Now here's the deal. Is x by itself on the right side? No, because there's that minus 1. So how do I get rid of the minus 1? Well, first of all, let's figure out this side of the equation. What is log base 3, 243? Control 10 to the x next to 1. log base 3, 2, 4, 3, hit enter. So this gives me 5. So this whole left side of the equation is going to be 5, which equals x minus 1. So 5 is not the answer because x is not by itself yet. I'm going to get rid of that minus 1 with my last step, plus 1, plus 1. 5 plus 1 is 6. That'll do. Cool. So again, if there's any coefficient out front, divide, turn it into the log on the left side, and then if you need to, there might be a last step, okay, to get rid of a loner. All right, last example. Now this, before I mess with anything here, you see I got a loner minus 23. I should add 23 to get rid of that loner. So now I have 3 parentheses 5 to the x plus 2, which equals 4, 6, 8, 7, 5. When I add that together, I have a number out front. So again, I'm going to divide to get rid of it. When I divide, I end up getting 15,625. All right, so now I want to convert this into a log. So I'm going to write the word log. The base becomes my little base. The argument is now 15,625. That equals the exponent, which is x plus 2. Okay, now I can type this log into the calculator. Control 10 to the x, base 5, 15,625. I end up getting 6 on the left side. X plus 2 is still on the right. My last step is to get rid of that plus 2, so I subtract 2 on both sides. And I end up getting 6 minus 2 is 4. PowerPoint is the same steps. You probably noticed that they have everything flipped around, but however you want to show that should work. Okay. So there's your example 3 and 4. So what we're going to do is pass out 10.5 assignment. You want to work on that. Make sure you've done 10.4, 10.3a, b, and c, 10.2, and 10.1, because we are going to review and test soon. So make sure you get that done. All right. Let's pass out that 10.5 assignment.